Uh, Ladies and gentlemen, business partners, dear colleagues, let me shortly introduce myself. My name is Jakub Mascuch. I'm head of LORCA laboratory. Abbreviation LORCA covers Laboratory of Organic Rankine Cycles and their applications. I'm going to talk about one of our projects. We have developed wood chips boiler, which produces heat and electricity. I'm going to talk about cogeneration, which means combined heat and power production. And this project is focused on micro-cogeneration, which means power less than it's obvious in power generation, as we know. So it's part of a new power generation sector, which is sometimes labeled dispersed or decentralized. Power generation. Cogeneration is the most efficient way how to produce or how to work with energy, and we focus on biomass, which is maybe the most perspective renewable energy source in our country. And biomass is also a fundamental part of national climate and energy strategy. I'm going to talk about one specific project, but the research and development of the cycle is and was quite long time run. We, during the development of the technology, it's clear that we are not able to work without strong industrial partners who are qualified in their sectors. What is maybe interesting to notice that our prototypes are working together with energy system of the UC building, and for now we covers something about 100% of heat demand of the building. For today we produce more than UC need, but if the winter is ongoing, we are able to cover heat needs of UC, and we produce around 10% of electricity demand of the day here in UC. What is organic Rankine cycle and why we choose WAWE? Organic Rankine cycle is one of the thermodynamic cycles. It's the way how to transfer the heat into mechanical work, and then transform into electricity. William John McCord Rankine was Scottish engineer. He lived in the 19th century, and he was one of co-founders of thermodynamics as a scientific area. And he was also focused on, he was mathematician, and he was focused on focused on sea wave behavior and description. So we take the WAVE label to our unit to thank him and to be clear that we were inspired by him. And the process loop is quite simple. You can see that we put fuel. I've mentioned we use biomass into the combustion chamber, and we then use flue gases to heat, to evaporate and superheat our working fluid. Then we transform some specific part of the heat into mechanical energy and then into electricity, and the rest is flowing into the condenser, and we produce heat. After condensation, the working fluid is received and feed back, and the loop is then closed. Cogeneration or combined heat and power production means that these two types of energy are produced together. Here you can see parameters of near market unit. The technology is placed into standard ISO container. On the left side you can see biomass storage and burning chamber and the heat exchangers, and these components are quite comparable to our competitors. But on the right side there is something, we call it engine room, and this is the core of the unit where we are able to produce both electricity and the heat. So this is the difference between standard technology and what we add to the standard technology. On the left side, when we look at parameters, standard technology here have consumption of electricity, and we are producing electricity compared to the competitors. This is possible only with in-house developed components. The core of the unit is electricity generating. We use rotary vane expander. I'm very proud of this part of the technology. Václav Hodička, colleague who is responsible for more than 10 years of research and development in this field, he is one of maybe 5 people around the globe who are able to design and to operate this type of technology in ORC. And the requirement was to follow simple construction and to be able to achieve nearly maintenance-free operation. In terms of heat exchangers, now you maybe see for what are those tubes in UC ball, as we can see here on the picture. So these tubes are used for transferring heat from flue gases into the working fluid. For our technology is specific that, and it's quite extraordinary, that we use direct heat exchange. Only a few producers around the world are working with this direct transfer from flue gases into the working fluid. Usually they use oil loop to separate those loops. Now you can see the picture of the real unit. You can see combustion chamber and the bottoming of heat exchangers here. Almost all of parts of the technology have its own ongoing development projects. In terms of combustion chamber, we have to work on it to, technology is based on 25 years of experience of our business partner, but still we have to improve the technology to be able to achieve new requirements, especially from the air pollution area. And we are improving the technology to be able to use especially low quality biomass. There's a quite strong request from the industry for these type of solutions. And connected with the design of combustion chamber is a greater system, because combination of greater and combustion chamber allows us to use quite extraordinary biomass and possibly some types of wastes. On the picture, you can see ash container to be able to simply put ash outside the unit. The whole technology is built up in a standard ISO container. On the right side, there are, as I've mentioned previously, combustion chamber and heat exchangers. And here, on the top of the picture, there is a system for automatic cleaning of heat exchangers. And on the left side is previously mentioned engine room. So you can have idea how it looks and how it works. And this is a container which is in front of the south facade of USIP. You can see it in operation there. To be able to market this type of technology, we have to pass a lot of legislation things. We have to fulfill a lot of requirements. The need is to fulfill something that is labeled eco-design, which is necessary to fulfill from the January of this year to be able to market the technology. Eco-design measurement have two important groups of things to solve. One is emission controlling, and the second is efficiency of the whole unit. As you can see, this picture is from measurement here at USIP. So we are very proud of that we fulfill these requirements, and we are preparing in these days technology for the total certification. So this project is was not working as itself. It is connected with projects around the technology. It took more than 10 years to get to this stage, and for our future, it's important to pass eco-design, to improve lifespan and durability of especially expander, and we are strongly focused on reducing manufacturing costs to be competitive on the market. Thank you for your attention, and I also would like to thank Technological Agency of the Czech Republic for supporting.